In section 3.5, we'll tackle naming acids. We'll name binary acids consisting of hydrogen and a monatomic anion, and we'll name oxyacids consisting of hydrogen and a polyatomic anion. Let's begin. Acids are a special class of hydrogen-containing covalent compounds that, when dissolved in water, release one or more H+ ions, also called protons, forming an anion with a -1 charge for each H+ ion that was released. These ionizable hydrogen atoms are written first in the formula, making them easy to identify. Binary acids include hydrochloric acid, which has one ionizable proton, and the monatomic anion Cl-. Oxyacids contain one or more ionizable hydrogens and a polyatomic ion. When an acid has only one proton to release, we classify it as monoprotic, while sulfurous acid, with its two ionizable hydrogens, can be called diprotic or polyprotic. Can you classify each acid as being monoprotic or polyprotic? If the acid is polyprotic, how many ionizable hydrogens does it contain? Binary acids contain ionizable protons and an anion from group 16 or 17. To name them, add the prefix hydro to the root name of the group 16-17 element, then add the suffix ic and the word acid to the end. Let's look at an example. H plus chloride, HCl, becomes hydrochloric acid. Keep this in mind while working through the next examples. Can you name the following acids? Be careful when spelling the name of HF. Oxyacids have their own naming convention. You'll take the name of the oxyanion, or polyatomic ion, and trade suffixes. Ate becomes ic, while ite becomes us. The prefixes per and hypo are retained, then you stick the word acid on the end. Let's look at an example. Suppose we're working with HClO4. We recognize this as an ionizable proton attached to the perchlorate ion. Perchlorate becomes perchloric, and we tack the word acid on the end. Table 3.5 summarizes the acid nomenclature rules with examples, including how to handle HCN, a polyatomic ion that ends in "ide", just like our group 16 and 17 anions do. Take a minute to review these examples, then try the problems on the next slide. Can you name each of the following acids? Remember to decide first if you have a binary acid or an oxyacid, since they have different naming rules. As always, I'll leave you with the parting thoughts of the authors.